Today, I have the pleasure to host Jacopo and Ciro. Both of them are the founders of Bauplan. Hi, Jacopo. Hi, Ciro.
Hi.
Hi there. Thank you very much for having us.
I'm super happy to have you. And can you start first by introducing yourself? Then let us know more about your company.
Sure.
I can start.
Go ahead.
I'm Jacopo. So 10 out of 10 for pronunciation. Congratulations on that. It's not very easy. Everybody calls me Apo, so that we can usually don't go through all the process. I'm the CTO and founder of Bauplan. I used to be the CTO and founder of Tuso, which was our previous company. The previous company was doing mostly NLP for information retrieval. And then after the company got acquired, and we led AI and data at the acquirer, we decided to build a second company, which is Bauplan. As it's not our first, it's our first company. As I always say, fool me once, shame on you, but fool me twice. So it's not exactly, we didn't know what we were gonna get into. So thanks so much for having us. And of course, big proponents of the open Lakehouse approach. So I'm sure we're gonna talk a lot about that today. Ciro, up to you.
I am Ciro. I'm the co-founder and CEO at Bauplan. I'm also from the team that built Tuso. We co-founded a company together, and we stuck through the acquisition, the IPO, and all that. Yeah, I spend most of my days doing machine learning, NLP specifically, and then kind of like built incidentally a lot of data infrastructure to support those use cases. And when the time came, we kind of like wanted to build a platform that we think is, to a certain extent, is a platform we wanted to have when we had to build a lot of those platforms to support machine learning and especially like the data management, the data transformation thing. And Bauplan effectively is a lakehouse, is a kind of like a very simple and Pythonic lakehouse. There are a number of assumptions in what we're doing around that. But I guess like the gist here is that we focus a lot on data transformation and data management. We definitely buy into the open lakehouse design. And Bauplan is, in one word, is the simplest data stack that we could think of, because we think that data platforms are honestly too complicated.
Yeah, and I can get your point. And I saw like Jacopo shared with me let's call it a blueprint or a paper you wrote about the Lakehouse. Can you maybe both of you walk us through this paper, and then we can talk a bit about the Lakehouse?
We're talking about the one at VLD.
Yeah, I think so. Yeah, the
Okay.
spare parts one. Yeah,
Okay.
the general philosophy. Like, so when we set out to build this,
papers, sorry.
Yes, it's So it's hard to remember which one we did when, how, with who. But the general feeling, and you can find the same idea in many of our writings so far. It's kind of twofold. One, Lakehouse is a fantastic idea. We did our first company stack on the data lake. It worked for us, but it was kind of like meh. Then we went to leave the warehouse world. It worked for a certain reason, but again, meh again. And when we find out, the original vision of the Lakehouse, but Reynolds, May, a bunch of other people's like, oh my god, this is awesome. This is obviously when the next data stack, when the enterprise data stack of the future is gonna be. And we like the object storage layer. So point, like, we really like the unified data stuff, and we like a lot the optionality in the compute, which gets me to the second point. So if you get this lakehouse idea, when there's a unified data layer, you manage data together, and data is object storage light and compute is all ephemeral, then you can go and pick and choose different compute model for a certain things, which get to our second, let's say, unique insight that we have, which is there's an entire class of data workloads that are better served by a fast runtime, like functions as service. You can think of like AWS, that are not as well served by other, typical compute model on the Lakehouse, like, the one job per cluster model or the SQL engine model. So fast are no certain in between, and I'm sure we can go into that more. But like, we highlighted that as kind of like a missing niche in the market of like, we love the Lakehouse, we love the openness. There's a bunch of stuff that we can run without asking clients to move out of their object storage, their Unity catalog, whatever. And the price performance of this certain specific set of market is better served by functions as a service. So the only thing left to do was to build the freaking thing, which of course is a lot of work, but we wouldn't have started if we didn't have at least this general view of how we fit into this broader ecosystem that has been pioneered by the Lakehouse paper by Berkeley and Databricks.
Yeah, that was, I think, back in 2020, if I'm not wrong.
I think maybe a bit later, but it was the Cider. What the one referring was the Cider paper, which is like Berkeley, Ali, Matei, and Reynold from, of course,
Yeah.
Databricks, and a bunch of people from Berkeley. Yeah.
And I think it's very important to let people know that for the Lakehouse, we're bringing the best of the two worlds, like the best of the data lakes and the best of the data warehouse in one word. And this is super important because in the data warehouse, you had to, for example, if you are scaling the compute, then you're automatically scaling the capacity, which was big, like pretty expensive. So now the goal is maybe like bring the cheapest storage you can have, as you mentioned, blob storage, and then you can bring the compute on the top of it. Like you can be storing 1 terabyte of data and using maybe just a small, like the smallest, I don't know, VM you can have on Azure, AWS, or whatever cloud provider, and you're good to go. And I think this was a very, very big change. And also the fact that you no longer had like this vendor lock-in, like this storage, like installed, I don't know, in specific format.
Yeah, we were very good customers of Snowflake, which is an incredible product, by the way. But the migration took a long time. Like you get in and then it takes like a long time to get out if you ever gonna get out.
Yeah, now you keep the data, whether like you're storing on, I don't know, Delta, Iceberg, Hoodie, and you have a bunch of frameworks like Apache Xtable. Databricks released the Uniform, like before the acquisition of Tabular, where you can do this conversion from Delta to Iceberg and Hoodie. Now it's supported natively, which is super cool. But
yeah,
I want to go back to your to the product you did build. How can we get started? Which maybe framework or language you're supporting? You talked about functions as a service, so this is something also I believe you're built on the top of your platform.
Yeah, I think absolutely. So it's essentially built on top of object storage, and for now our table support is we support the Iceberg. That is not a terribly important choice for us. Like I think depending on what you want to do, you can support different tabular formats. But the important thing is that the developer who's writing the code, and in our case is Python. We're very Python centric these days. We support SQL as well as an important language for both transformation and especially for interactive queries. But really, the bulk of the beauty of the experience shines when you do Python. And what I was saying is that take like the case, for instance, of different tabular formats. You can have different tabular formats, and you can have very good reasons to have them. And it's kind of really up to you. Should the developer care? And the short answer is no. So everything that happens in your code and in the way in which you organize your business logic should be abstract to the point that your code is essentially declarative and nothing else matters. So if you swap, an Iceberg table for a Delta table, your code should not change. You should have a way to declare that table using the most abstract common denominators that you have across all this, which in the case of a table is very abstract. It's literally whatever has rows and columns, and I can apply filters. So when you start thinking in this perspective, a pandas data frame, an arrow table, Parquet, an Iceberg table built on Parquet, a Delta table, those are all the same for your code. Bauplan is built on this concept that is the simplicity of development that matters. We chose Python for a number of reasons. One I think is very simple, is just like the experience in Python is particularly broken. It's not easy to run Python in the cloud. And there's not really one way of doing that. So companies typically have a hodgepodge of kind of like stuff that they did, and it becomes kind of like unmanageable and annoying quickly. But also the point is that I think that Python is a very important language for data. And oddly enough, there isn't a Pythonic data platform, not a real one, like not a one that was built for first principle for those developers. And it's a language that is growing massively because of AI. And it is the language that also, to this day, the first AI agents are most proficient in. So I think it's a language that will become like even more important for data. I would expect the future of data pipelines and transformation to be mostly Pythonic with some SQL, with a subset of the code written in SQL. So that's why we focused on that specific segment.
But as you said, like you're supporting both Python and SQL.
Yeah, absolutely. Because you can think of a lakehouse. Our thinking around that is this: like you can think of your data platform as an object that will support three main use cases, right? One is you interact with your data in real time. So you run a query and you want to say how many rows are there in this table, how many nulls. You want to do a join or something like that. And that is done obviously in SQL because there's so many advantages. It's such a simple language. Plus your query engines are all SQL based. So it totally makes sense. There's absolutely no reason to move the developer from this point. Then the second use case that you support is that there's somebody who is iterating on something that is a little bit more complicated than just a query. It can be a pipeline, it can be training a model, but we're still in that moment where the developer is iterating. And so we're still kind of like, maybe we're in a notebook. And then there's, whatever we did typically is going to look like a pipeline. We want to run it in the cloud at scale on a schedule with all the retries, with all the tests, the CI/CD. We want to make sure that this is now a production ready application. The problem that we see with the data stack, and I have to say that the Lakehouse offers the possibility to change this, but to this date doesn't really solve the problem, is that for these three use cases, you have three different infrastructures. In one case, you have a query engine. In the second case, you might have a single node Spark cluster. In the second one, you're going to have like a cluster. You have different abstractions and different interfaces. You run, in a SQL editor, or you run in a notebook, or you run now in your IDE. So there's this idea that your platform has to be three things to support these three use cases. And I think the largest bet that we're taking with Bauplan is basically saying, for the vast majority of your use cases, when it comes to data transformation, you don't have to have three infrastructure, three interfaces, and three type of abstractions. Things can be radically simpler than what they are. The way they are is just an historical byproduct, and then people adapted to it. But you can actually do everything as a function. Everything's going to look always the same in the backend, in the infrastructure, and in your interface. You write your code in your IDE always, and you just iterate on that.
And if I'm like, suppose I am, I don't know, a data engineer and I want to get started with Bauplan, is it a framework? Is it a CLI that I should install? Do you have any library that I can start leveraging and get connected to your platform? And also, what about the compute? Because I've seen that you're saying that like zero infrastructure management. Is it like those like serverless functions?
It's a let's say it's like a lambda for data, if you will, in the sense of like the compute is managed by us. You start with Bauplan by doing pp start Bauplan, and that's literally the only thing you need on the client side. And then you will need an API key that connects your client, like your AWS config. It's called Bauplan config. Imagine the creativity there. So the Bauplan config will just, with the API key, connects to your remote compute. The trial version that you have online now, you can log in. It's public data set, so it just share with with adopters. You can just try it out to see how it feels. You can run all the example, but in a real setting. So our customer have their own, of course, organization when they can generate their own IP key, and then every time they run, this will point to the compute capacity that they have reserved. But the compute capacity is managed either in their cloud or in our cloud, but is managed by us. So the developer never see anything else that is not a function or an API call. And then everything that happens between then and the actual infra that needs to happen is on us to make it happen in a pure, fast kind of mentality. So it's very similar to other serverless offerings that, of course, you're familiar with, but very different than, I don't know, EMR or this type of experience that you have, for example, with AWS building blocks for similar cases. I don't know if you see them very popular in your day-to-day life, Joseph, as well.
So I will make sure, this is something important you mentioned, that we have the trial version. So I will put the link so people can try Bauplan.
Thank you.
And also, I was curious to know, your compute, is it are you cloud agnostic? Like you will run on every single cloud provider, or you have preferred one, or one where we are more mature than the others?
We're definitely more mature on AWS. These days, we're focusing more on AWS. One simple reason is market share. The other is actually the fact that I think AWS in particular is the cloud that historically has been more faithful to remaining a toolbox more than a platform. So you can do a lot of stuff in AWS, but is usually kind of like spare parts. Data platforms built on AWS can become gnarly, can become very hard to maintain very quickly. I think we have a particularly compelling value proposition there because, we focus particularly on those companies that today have essentially want to scale their operations without having to scale their data engineering team. Bauplan effectively does a lot of the job that a data engineering team does. And so if your company is in that situation where you have, 1, 5, 10 people at most, and you think you're going to do way more with the data, but what you see is if I have to scale the platform now, I have to hire more people. This is going to become more complicated. I have to really think about how to organize my team. My pitch to you is like, maybe you don't. Like maybe you can keep your team as it is. We abstract away all the infrastructure and we give you back abstractions that really a general developer understands, as opposed to, oh, I have to hire now a person who really understands Spark, which is like, it's a great advantage, especially if you want to hire new folks, because essentially like anybody can, it's just Python. Anybody can work with Bauplan. And generally speaking, I think like Spark is the role of Spark is an important piece in what we're trying to do, as in like Spark is a very foundational technology for data, and it's very widespread and it's very sticky and it's very reliable. But it's also now, it seems that there's a fair amount of workloads that are not on Spark for a good reason, except for, like we built it on Spark a few years ago, and now that's what we have. But it's just like machines became like so large now in the cloud. And I guess like Spark came out in a moment in history when the largest machine you could have in the cloud was smaller than Lambda today. So of course you needed everything to be distributed. But there's an argument to be made today. It's like, well, most enterprises actually, I don't know if you ever looked at the Redshift paper that reported how, like, the size of queries and workloads. Most workloads actually tend to be like an order of magnitude of a few gigabytes, few hundreds gigabytes, like rarely go over a terabyte. And all those workloads can be drastically simplified by using a much more intuitive way of doing things, like, hey, here's a function, it's just a Python function running in the cloud, is a special runtime built specifically for this purpose, but to you is going to look like just running a script and submitting to an API. And then of course, for the super large stuff, please keep using Spark. But there's a lot of overhead in my experience, in my past experience, especially, that teams have to go through in just like maintaining a lot of distributed data frames, APIs, and distributed systems for workloads that are honestly not that big.
I'm curious to know, you mentioned that your data remains in the blob storage, then you just need to connect Bauplan with the blob storage.
Mm-hmm.
Which means like you mentioned that for now you only support Apache Iceberg. So I believe you get connect to the Iceberg REST interface, REST catalog to list the tables. But like, what about the governance part? For example, if you're using, I don't know, you've seen like many vendors have now their own catalog. So can you interface their catalog, or you can say bypass them and access the data straight by reading the Parquet files or whatever files you have there?
So Bauplan comes with a catalog. So Bauplan comes with a catalog that allows to do a number of things that are very important in the way in which the developer workflow that we designed works. In particular, it comes with a catalog that has Git-like abstractions over tables. So typically, the developers that use Bauplan today use the platform to create branches where they zero copy their data into a branch. Then they build these pipelines using these serverless functions, and then they can deploy as in like merging back into the main branch. We typically have integrations with other catalog because I don't think it's a very good idea to have a million catalogs, but also I think like people spend way too much mental energy on this. Like you choose one and then you kind of, you can write into your single source of truth and it's fine. I think like that battle is probably going to be won by Unity because it seems to be like very, omni-encompassing. And we have like a bunch of customers and users who, come to us and they go, okay, whatever you want to do, this looks great for certain use cases. It's very simple. It's very quick. It's much cheaper, but I don't want to move stuff from Unity. It's like, totally understand. I also don't want you to move from Unity. I definitely don't want to go there. And so you write back into the final catalog and you inherit the governance from that single source of truth. I'm not in the catalog business. My runtime comes with a catalog just because it provides a beautiful ergonomics for the developer.
Yeah, and I saw in your the website how you push for this less complexity, more robustness with this branching of data and like simplifying the CI/CD component part, which is essential for every single project.
There's a lot of stuff that the data world kind of like it reinvents and calls it in a different name, right? Like it's a strange thing that happens. It's like, I have a medallion architecture. It's like, you mean you have branches and a CI/CD? Like, or it's just like, no, this is a different thing that we do. It's like, okay, I guess. But like, ultimately, I think there's a lot there that can be simplified and push, the data engineering world to become like more uniform with software engineering. First, because like if we all speak the same abstractions, I think like it becomes like much easier to organize teams and be productive in organizations. And secondly, because honestly, software engineering is it works. Like we know what we're doing there. Like we built very impressive machines at scale using those best practices. So I think there's an advantage in pursuing those.
And if someone is interested, to whom he or she can reach out in case they have questions, do you have any specific email or just reach out to you directly?
I think the
I mean,
best way would
we're very easy to reach.
yeah.
You can just either go through the website and and sign up for an account. You can reach out on LinkedIn. We're very easy to reach. You can write us an email. Our address is our first name dot last name at bauplanlabs.com. So probably you should write to Ciro because it's a much shorter name and a much shorter last name compared to mine. But yeah, you can reach out anytime.
Bye.
Ciao.
Hey folks, welcome back. This is part 2. We have, as you know, Jacopo and Ciro. In this second part, you're gonna show us the platform and how it works.
Okay. Well, thank you very much for having us a second time. It's good to be here. We were discussing before, like we change everything: location, haircut, shirts, So I'm gonna do something very simple. So I think like last time we discussed how we thought about like an execution model and a certain way of exposing the abstraction of a platform. What we want to do today is showcase one particular use case of Bauplan working along with an AI system. So basically, if I have to tell you kind of like the story end to end, this is the assumption is that a lot of the work of data engineers and a lot of the work of our early customers we're already seeing is starting to become work that they aim at automating using AI. So like a data engineer does a fair amount of repetitive and kind of, dull tasks, especially when it comes to debugging and looking into several things that went wrong. I think like I can actually share my screen. But effectively, like you can think of a system in that is you can think of a world where your data engineer will start working with a bunch of automated systems that can help with the kind of things that are not terribly distinctive. You don't want your data engineering team to spend a whole lot of time on that, like, ETL or data cleaning, like generating quality tests, and most importantly, fixing pipelines, which for anybody who worked in data, it's a fairly hard and complicated thing to do. And I don't think anybody thoroughly enjoys this. So we're going to show you today, like how you can use like our platform, which is designed as a code first platform to basically use an agentic system. Agents are very good at code. They're not so good at UIs and GUIs. So anything that is like API first works very well for you to bring this kind of automation. The kind of problem that we can think of is, well, there's a pipeline that breaks. There's a number of things at that point that you need to do. You can do like a root cause analysis. You can start thinking about what went wrong. But ultimately, one important thing is that you want this automation to be end to end. And so you want also AI system to use your data platform to fix stuff. Okay. And that implies that your agent now will have to actually not only read the data from your data lake or your lakehouse, but actually do something and write potentially a new table, write a new pipeline, change a columns, do something else. And so when you allow a system, like an automatic system, like an AI system, to do something in your data, it's okay to be nervous because the agent can do a number of things that are not necessarily the things that we want them to do. So for instance, like what if it installs a malicious package, or what if it just like changes a table or an artifact that other systems will depend on downstream, and that will be pretty problematic in a production environment. Now, the good thing of that is that last time we discussed the function as a service model for execution. That is a part of the design of our platform that allows to have full isolation when it comes to the runtime. So the agent is essentially now operating with separated functions that are completely containerized and isolated one from another, and isolated from the host. So there's a limited amount of things that it can do like the malicious and potentially catastrophic problems. Like the agent now is sent. The second part is the data, and last time we discussed like this abstraction of Git for data over open formats. A specific case is Iceberg, and so at the end of the day, what I'm going to show you is if you have a platform that is built for full auditability, that has the system of Git for data and is built for kind of like rewards isolation and being pedantic, you actually can use an AI system to automate a good deal of the work that your data engineering team, not only your data analyst, your data engineering team is doing today. Without further ado, for this demo, we're going to just like use Claude Code. I'm sure that most of the folks will be familiar with that at this time. But the real, like the situation that we find ourselves should be something like this. You have a, you might, I'm sorry, this is, your initial situation would be something like this, where you actually have a bunch of things in your data platform that didn't go well. So imagine that one of these is a pipeline, a transformation pipeline that takes some raw data, transforms the data into a table that is consumed by a downstream users or application, and that this pipeline failed. It failed during the night, maybe it failed while a certain job was running on a schedule. The job of a data engineer today would be to go here and fix it and understand what went wrong, if it is a problem of the data, if it is a problem of the code, if it is a problem of the infrastructure. What we aim at doing is automating a part of this. So for instance, I can go in a place like a Claude Code and say, hey man, can you tell me what jobs failed in the last, I don't know, 5 hours. What the system then will do is that we have an AI agent, in this case, Claude, that interfaces with the data platform, with the data stack using an MCP server. And because everything is exposed as code, it's particularly simple to do that. So you have something like this, just like, well, in the last 5 hours, this is what happened. It's like, okay, so can you tell me what went wrong there and do a quick root cause analysis? Make sure to include your suggestion about what to do. With the same logic, now all the APIs of the platform can be explored with the MCP. So now the agent can do and just like get all the metadata of the files of the tables, run queries potentially inside of the tables to see what went wrong, scan through the logs of the system that are also exposed as a Python API, and understand, like in the scenario that I was mentioning before, what exactly should be done, because it can be in principle a problem of data or the code or the environment or all of them. Like it's an undetermined problem when we see just a pipeline failing. You don't necessarily know what happens. Okay, so in this case, probably what went wrong here is going to be a mix of data and infrastructure. Knowing these jobs, as you can see, we have already our first report that says like, well, there's a problem with the environment. So it appears that we have some Python and pandas and NumPy compatibility problems. So there's a function somewhere that is not running correctly because of this. There's another case where there's actually a problem with our data modeling. There's a column that is missing. So the recommendation is to fix this in a certain way. Now the question is, as I was mentioning before, can I have the agent actually fix this? Like, this is very nice, and it's already, you can think of this like this is a demo pipeline that is like fairly simple, but you can think of this like on a most gnarly and complicated pipeline. This is already saving you hours of your time that otherwise you would invest in digging into the logs and do all this by yourself. But the real deal is, okay, can you fix it for me? Because, it's great to know what went wrong, but I actually would like to have, this thing fixed. So that's what we're going to do. Let's take let's take one of them. Okay. So for instance, you have first one here, and say, can you help me fix this job right here. I want you, and this is where the ergonomics of the platform comes in, because we're going to ask the system to open a branch, open a data branch, and change the pipeline, run it. And when you think you have figured it out, write a report and give me back the branch so I can take a look at it and merge it. This is only possible because there is the Git for data abstraction in the background. It's the only possible because otherwise I would be very nervous about an agent changing some code in a pipeline and running a pipeline in my production environment, as that would change effectively the status of a table, or will change the behavior of downstream applications. And if I don't have a quick and simple way to isolate the agent while it does this, or a way to roll back, in both cases, I would be extremely nervous. Like, if you think about it, one of the reasons why code generation is so popular. Okay, it's already fixed those. Identify the trouble. One of the reasons why code agents are so popular when you do code generation is that you can roll back. You have Git. So even, besides the horror stories that you read on Twitter of people having, cursor doing something terrible to their application, but generally speaking, is a reasonably safe environment where you can guardrail the agent enough when he just writes code. When he writes something like a data table in your application, it's a completely different ballgame. And so I think it's an interesting point that the combination of this data branching system, which creates this new branch here, is fixed NumPy compatibility. Okay. And then just changes the code, and is actually able to run a project from scratch and create new tables now. And finally, give me a report with my new pipeline. This is what happens. It seems that it ran correctly. But now I do have fundamentally a branch that I can check out to. If I switch to my terminal, what I will do is I'm going to check out to this branch. And now I can explore the branch and see what are the tables that were created by the agent, and see potentially explore the data myself, understand what's right, what's wrong. And if I'm okay, I'm going to merge this table now back into main. Sorry. No, this is my.
No, it's not the right branch, I think.
It's not even a branch. This is
you put the table instead. Yeah, it's the table name instead of the branch name.
It's the table name. There you go. Okay. So now we should have our fantastic new table, which is called top pickup location. Get. There you go. So we have it in main. So all the work that would have been done by a person, the bulk of it has been automated by a system. And for the purpose of this demo, we like to show this as an interactive flow using Claude code, where you can chat with it. But this is ultimately an AI system. The important thing here is that you have an AI system that can access fully a data platform that is designed to be kind of AI ready, because it's API first and code first. It's very easy to think of this system as a system that now just runs asynchronously. So instead of having my terminal and do this myself, I have a bunch of prompts, and I just have an agent that wakes up whenever there's a problem. And so instead of waking up in the morning with a bunch of failed jobs and, little indication of what happens, what you will have is a bunch of failed jobs and a bunch of attempts to fixing these jobs by an agent. And so my job now is to review the work that the agent did while I was sleeping, instead of doing something else. The example here would be, if we take another job, for instance, right? You have it will look like this, right? You will have automated systems coming to me with a job that's completed, and I can then inspect the job and say, it's okay, so this is what the agent did. This is the logs. This is the code, and these are the branches. In this case, it's like this job ran on main, for instance. Like this is the branch where I should check it. But your work changes pretty radically in that sense. Like you become like more able to like you can do much more, just like managing the swarm of little agents helping out rather than doing this yourself.
That's
Does that make sense?
Yeah. I think now I can fit the presentation you did and the demo.
Okay, fantastic.
Awesome.
Anything
What
to add?
do you need? Do you need the slides from our side? Do you need anything else to be part of the montage, like of the final cut, or the video is enough? Like, do you need any material that you want to interleave in the?
You can just give me maybe some documentation that I can add to the description of the video, like beside the website. Like if you have any code or stuff that I can add, so people maybe if they want to try it.
Oh, okay.
Okay, fantastic.
We can leave a link. Yeah.
Okay.
Let me just do the closing first. Thank you so much, Ciro and Jacopo. It was very
Thank you,
interesting
Yuzo.
to get to know Bauplan, and also having a look at this interactive demo. And as you can see, it was really live coding. You've seen like Ciro messing up with the wrong table.
I know you
Yeah.
mess up, like, but it think like it gives. I don't know. I'm so tired of like those like canned demos.
Yeah,
Like at this
super
point, like
immersive.
this is an actual
This is
system. Like our
reality.
our
This is
customers
reality.
actually
This
use
is
it.
how it
works.
This is real.
Yeah.
This is real. This works.
Also, it's very hard to mock demo with Cloud Code in general. Like the other thing is that even if we wanted to mock a demo
is
with
true.
Cloud Code, it's actually impossible because the system fight against you mocking things. So this is real, even because we can't pick and
Yeah.
fake
This
even
adds
if we
an
wanted
extra
to.
layer of
Yeah.
thrill, because like not only your demo can fail, but the agent,
Everything can fail.
it's non-deterministic. So whatever.
Yeah, exactly. You can ask the same question twice, you won't have the same answer. And that's
Exactly.
the beauty of the LLM.
Yeah. So yeah. Okay.
All the material will be added to the description of the video. And if you have any questions, feel free to reach out to Ciro and Jacopo. You're going to have their contact in the description. Thank you so much, guys.
Thank you
Thanks
very
again,
much for
Jeff.
having
Thanks,
us.
everybody.
It's been a lot of fun. Bye.